Hello students, as I was about to begin the lesson 8 video, I thought it might be a good idea just to review synthetic division really quickly. I think I have one long division problem in this video as well. Wanted to remind you of a couple things. Synthetic division only works with linear factors. In other words, it has to be like an x minus 1 or an x plus 3. It can't be a 2x plus 1 or a 3x minus 5. It's got to be x plus or minus something. So also don't forget that you need placeholders. You need zeros as placeholders, and we're going to talk about that more in a minute. Let's go ahead and get started. Okay, so this was originally a classwork that you would have done if we had been at school. So I just thought I would go over some of them with you. So we have this really long polynomial divided by x plus 2. And since it's x plus 2, we can use synthetic division. I want you to remember that the x plus 2 is the factor. What we're asking ourselves is x plus 2 a factor of this number? What that would mean is that there would be an x-intercept, but the x-intercept would be at negative 2. So the root is at negative 2. So that's the number we're going to use. We're going to use a negative 2 here. And then what I sometimes like to do is I like to use my highlighters, and I'm going to use a really light color here. And what I will do is I will look at the highest degree, and I will say to myself, okay, I know that this needs to be x to the 4th power, so the coefficient of x to the 4th power. And so I use my highlighter, and I'll draw a 4. And it's really hard to do with this highlighter because it wants to do straight lines. And then the next one needs to be something x to the 3rd power. And the next one needs to be something x to the 2nd. And then something x to the 1st, and then my constant, I can either put a 0 here, or I can put a c, or whatever. And then what I'll do is I go back and get my pen, and I will write in the coefficient over this. But it'll help me to kind of remember that if there's not an x to the 3rd, or if there's not an x to the 1st, I need to put a 0 there. Now this polynomial has everything it needs. It has an x to the 4th, 3rd, 2nd, 1st, and a constant. So this is not as important here as it would be if you had where you had to put a placeholder. So my x to the 4th coefficient is a 1. My x to the 3rd is a 12. And then just go on from there. That's my x squared, my x to the 1st, and my constant is a negative 8. Remember, you always bring down your first coefficient, and then you just start multiplying and combining. So I'm going to multiply what's down here. 1 times negative 2 is negative 2. Oops, negative 2, and then combine the 12 and the negative 2, that's 10. Negative 2 times 10 is negative 20. Combine these, and that is an 8. Negative 2 times 8, negative 16. Combine, that's negative 5. Negative 2 times negative 5 is 10. And combine these, and you get 2. Okay, so at this point, I also look and I say, okay, if there's an x to the 4th is my highest degree, then this is going to be an x to the 3rd. Sometimes I'll go backwards though. Like I'll put a little mark right here and just kind of separate this off. This is the remainder. Remainder, constant, x term, x squared term, and x cubed term. So basically this is my answer. So it's 1x cubed, which is just x cubed, plus, because it's a positive, plus 10x squared, plus 8x, minus 5, and then because my last term is a positive, I put a plus here, and that goes in the numerator, and my denominator is my original divisor, x plus 2. So this is the answer. Now, because there was a remainder that was not 0, this is not an x-intercept for this polynomial function. So x plus 2, we will say x plus 2 is not a factor. Of course, we could also make a statement that negative 2 is not an x-intercept, negative 2 is not a root, negative 2 is not a 0. Any of those words would work for that. So we're going to start to speed up this video a little bit. I would like for you to pause the video and see if you can set this one up and then come back and see if you did it correctly. Okay, so you should have set it up like this. Remember, if this is a positive 5, this is a negative 5 over here. And then you have an x cubed squared to the 1st power and then your constant. So those are just lined up across the top. So let's bring down bring down to 6, and then pause the video and go ahead and solve this out and see if you can determine whether x plus 5 is a factor of this polynomial. Okay, so these are the numbers you should have gotten across the bottom. And 9 is the remainder, so this is not a factor of this polynomial. Your answer would be 6x squared plus 2x minus 6 plus, and then your 9 is your numerator. Your denominator is x plus 5. So that means negative 5 would not be an x-intercept in this graph. Okay, here's another one to try. Let's try setting this one up. So pause your video and see if you can get it set up correctly. You will have a placeholder in this one. Okay, so this is kind of what it should look like here. On my line there. This is a place where you could use your highlighter and say, okay, this has got to be my x to the 4th. I'm messing this all up. This is my x to the 3rd squared, which there isn't one up here, so that's why I needed that 0. First power and my constant. Of course, you might not have to use that highlighter, which is awesome because it kind of does get in the way a little bit. Okay, bring down your negative 5. Go ahead and multiply this out and combine and see what you get, and pause the video and come back. Okay, so after I multiplied and combined everything, I end up with 2 zeros, and so I'm not going to even put those in my answer. So this one and this one won't even go in my answer. My answer is going to be negative 5x cubed plus 3 plus 2 over x minus 1. So x minus 1 is not a factor of this polynomial. Okay, let's try this one. So our root that we're looking to see if it is a root is 2. And then our coefficients are 1, negative 10, 22, and negative 12. Okay, bring down your 1. 2 times 1. Combine those, you get negative 8. 2 times negative 8. Combine those, and you get positive 6. 2 times 6. Here's one where we have a 0 remainder. So our answer is going to be x squared minus 8x plus 6. So this is another factor, and I wonder if we can factor this one again. No, you look at it and you think, maybe I can factor this again. That would be cool, because then I would know all the factors of this polynomial. But you think 4 and 2, but that doesn't work because it has to add up to negative 8 and multiply to 6. So that, yeah, we would have to use quadratic formula to factor this again. And sometimes that's possible, and we may get to one that we can do that with. Anyway, so x minus 2 is a factor of this polynomial, though. And when we divide it, this by x minus 2, this is what we get. And if we use quadratic formula, we can find the other two factors. So this is the last synthetic division problem we're going to do, and then I think we'll do a long division and be done with it. And this one looks kind of fun because it's missing an x to the 5th, it's missing an x squared, and an x term, so it has several 0 placeholders. So I want you to pause the video and see if you can set this one up and then come back. So that's what it should look like when you set it up. You've got your x to the 6th, there was no x to the 5th, negative 4x to the 4th, 2x cubed, no x squared, and no x term, and then there's your constant term. So pause it one more time and see if you can get the answer here and then come back. Wow, okay, so that one was really no fun at all because it didn't turn out to be 0, and it had some really big numbers that are irritating. But anyway, so this is my remainder, constant, x term, x squared, x cubed, x 4th, and x to the 5th. I want to remind you too that if you start out with your highest degree term being x to the 6th, then your answer should be 1 below that. So whatever your highest degree term is in your dividend, your answer, your quotient, should end up being 1 less than that degree. All right, so let's write our answer. It's 10x to the 5th plus 20x to the 4th plus 36x cubed. So I can write this a little bit better. Plus 74x squared plus 148x plus 296, I think these are all pluses, plus 600 over, what was my original? X minus 2. And the conclusion that we can draw from this is that x minus 2 is not a factor, which means 2 is not a root 0 x-intercept. Okay, so here is a long division review if you need it. First of all, remember that you are looking at the first term in the divisor and in the dividend, and you're trying to determine how many times will this first term divide into this first term. 2 divides into 14 7 times. X divides into x to the 4th, x to the 3rd times. And then you're going to multiply this times both of these terms. 7x cubed times 2x is 14x to the 4th. If you don't get the same thing here and here, you did something wrong. 7x cubed times negative 1 minus 7x cubed. Don't forget, before you do anything else, you got to change these to the opposite of what they were, and then combine. Okay, so these cancel, and this is going to be 2x cubed. Bring down your next term. Okay, 2x divides into 2x cubed plus 1, yeah, we'll just put the 1. We'll put the 1. 1x squared times. Okay, x squared times this is 2x cubed. X squared times this is minus 1x squared. Change them to the opposite. And then cancel the first pair. Combine these. This is negative 10x squared. Bring down minus 11x. 2x divides into negative 10x squared minus 5x times. That times that is negative 10x squared. That times negative 1 is plus 5x. Change them to the opposite, plus and minus. These cancel. When I add these two together, I get negative 16x. Bring down the plus 8. Okay, 2x divides into negative 16x, negative 8 times. So I can move this down a little bit further. Negative 8 times 2x, negative 16x. Negative 8 times negative 1 is positive 8. But remember, we have to change these to the opposite and then combine them. And when I do that, I get 0. So guess what that means? That means I have a 0 remainder. So that means 2x minus 1 was a factor of this. Now, if 2x minus 1 is a factor, then I can figure out what one of the roots is. If I set this up equal to 0, 5 by 2, whoops, that is a messy 2, x equals 1/2. What that means is 1/2 is a root for this polynomial function right here. All right, that'll do it. Moving on to factoring.